In this experiment, we're going to learn 4 flow meters for volume flow rate measurement, and then we'll compare the results from different flow meters in a water channel. Here is the overlook of the test facility, which is composed of a closed return water channel and a loop with the different flow meters. The flow rate in the water channel is controlled by 1 pump and 3 valves. 4 different flow meters are installed. They are ultrasonic flow meter, orifice plate flow meter, rotameter, and weir. The flow is operated at its steady state, which is the working condition for these flow meters. Load cells are set in the end of the channel to measure the weight of water. The water accumulated in time. Therefore, the temporal rise of the total weight indicates the volume flow rate. Note that these load cells have to be calibrated before being installed. Now let me introduce the working principle of these flow meters. The first subject is the ultrasonic flow meter, and we're looking at its digital meter. An ultrasonic flow meter measures the difference between the transit time of ultrasonic waves that are propagating and are against the flow direction. And the time difference here indicates the volume flow rate. Now we're looking at the orifice plate flow meter that is clamped between the 2 cylindrical casts. The cast is equipped with an upstream and a downstream pressure sensors. In details, we installed the orifice plates in the pipe with the inner diameter capital D. And the diameter of the orifice plate is lowercase d. Also, 2 pressure gauges are installed on the upstream and downstream to measure the pressure difference. This pressure difference is induced by the deformation of flow streamlines when the streamlines pass the narrower orifice. Substitute these parameters into the formula to obtain the current mass flow rate. Now let's look at the rotameter, which has to be installed vertically. There's a float in the rotameter. When the fluid flows through the rotameter, the float will be pushed upwards against the gravity. When the float reaches force equilibrium, the height of the float will correspond to a certain flow rate. And this flow rate reflects the relative velocity between the flow and the float. And in the meantime, it determines the total drag, capital F, in the balance. Now we come to the measurement in an open channel flow, which is achieved by a weir installed downstream of the top channel that is open to the air. With a given weir shape and the height of water level, we can acquire the volume flow rate. This is because the elevation of flow height is a consequence of the pressure. The pressure is built up due to the weir blockage, and it is a 1-to-1 function of the flow velocity. The relation can be approximated by the Bernoulli equation. Fully open the valve A and valve C. And adjust the valve B to produce different flow rates. Turn on the pump, Wait until the systems reach steady state, and record the readings from each flow meter. Then change the flow rate and orifice plate, and observe the difference.